Okay, great. Thanks very much. Thanks very much, Steele, and thank you very much, Anita, for joining us. My name is Tim Rodwell. I'm a physician and researcher in the pulmonary division, and I'm going to be introducing our speaker today, Anita Suresh, who's going to be talking about Seq&Treat, targeted next-gen sequencing for drug-resistant TB diagnosis. Next slide, please, Steele. So I've got the pleasure of introducing Anita to us today because I've been working with Anita for about 5 years. And I first met Anita when she came out of industry to join FIND in Geneva, which is a nonprofit for diagnostics, in order to make a more global health kind of impact. At the time, sequencing wasn't really much of anything. And essentially, Anita started the sequencing program with her and me and a few tens of $1,000s. And over the course of 3 to 4 years, she turned it into a global behemoth with a war chest of $20 million. So it's been incredibly interesting and a privilege for me to watch Anita's meteoric rise within FIND and across the world, supporting sequencing all the way from COVID diagnostics to surveillance to the first diagnostic ever endorsed by WHO based on sequencing, which Anita's going to be talking about today. So without any more ado, I will hand it over to Anita to talk more about the details of that journey. Welcome, Anita.
All right, Anita, I'll pause my share and you can take over.
Excellent, thank you.
Of course.
Thank you. Great, thank you, Steele, and thank you, Tim, for that very kind introduction. It's actually your enthusiasm and passion for this topic that has sort of kept us going through this as well. So I think thanks for kind of being the champion for this technology, which is already not something easy even for sort of when you look at a high resource setting. So I think to make a case for it in global health has not been easy, but in a way the pandemic was the one that in a way pushed it along a lot further than we expected within such a short span. So what I'll be talking about a little, focusing really on the TB work, but I think I'll also speak to some of our other experience or work across beyond TB and sequencing, because it's very much about our work at FIND is very much about establishing equitable access to diagnostics and technology and surveillance. And so we really work at the nexus of communities, governments, WHO and other such global bodies, as well as industry to really bring innovation really from where it is at to be able to be fit for purpose in these settings, in low resource settings, and so that they are also an integral part of health systems, not just sort of an afterthought or not event. So diagnostics really is the key, so you're not blind to what you've been looking at. So I think that's still a case to be made for that, and I think that's something FIND has been really working on for the last 20 years since its existence. And a number of other things. We're a collaborating center for lab strengthening and diagnostic technology evaluation. So that really reflects some of the work we do even for sequencing. A lot of it was generating the evidence to be presented in a way to WHO for global policy and hopefully further down for national policies and so on. So a little bit on the sequencing program itself within FIND. As Tim said, we really started as a little stealth group working just on TB R&D quietly on the side until we made a breakthrough with this large grant from United, Seq&Treat. And since then, we've been working on a number of other areas, pandemic threats, where we started on viral hemorrhagic fevers right when and then the pandemic hit. So very much focused a lot of work, like many of us, pivoted a lot to COVID, continued the TB work on the side. AMR has been something more recent where it's been other pathogens where they're really looking to say, hey, TB can be the pathfinder. Could we do something similar for some of these other pathogens? And our work has really been focused on 3 areas, on one being from the technology side, really enabling these technologies. Again, a lot of these great tools exist. There's a lot of development that has happened thanks to oncology and other areas. It really didn't need to be because of TB, but TB can take advantage of that. But it still requires a little bit of optimizing those workflows, making sure they're actually end-to-end and not just super flexible that countries have to decide and pick between 10 different options. And then doing the actual validation, generating the evidence, the clinical evidence to be able to utilize these with policy behind them to actually guidance to use them. The second aspect is very much in the knowledge base, so it's on the data itself. So a big part of sequence, you're generating so much of big data, how do you actually interpret that? So that phenotypic to genotypic correlation, the associations, being able to predict resistance to mutations, being able to understand variants and distinguish between variants and so on. So that's a big part, obviously, of sequencing. And I think we also want to be able to contribute to that so that there is a basis of knowledge on which decisions can be made, hopefully eventually clinical decisions as well. And the third aspect with sequencing, unlike an RDT or a PCR test, I can't just drop a box there or drop a kit there and hope it'll sort of be uptaken and there'll be millions of tests done. We actually need to enable the utility as well. How do we utilize this? How do we set up this workflow and so on? So a lot of the other work has been on implementation guidance, tools to actually help countries and labs be able to utilize this either for the current disease you're thinking of, or also to be able to expand to other diseases, as many labs have been doing as core facilities for their countries. So I might be speaking to audience that's very familiar with TB. So this is just something I usually have because we do end up talking a lot to people who are not as familiar. So again, the stats, if you've been working on TB, again, I don't have to reiterate, it's still unimaginable and really not right that something that's completely preventable and curable still sees about over 1 million deaths every year. And there's still 10.6 million falling ill with TB every year. This number doesn't change. It only keeps going up, unfortunately, not actually going down. And COVID-related disruptions actually made it worse. So the recovery has been quite a challenge, as we've seen. And of course, the whole aspect of multi-drug resistance, I think that's been a crucial one, and actually unfortunately exacerbating this, and then and hence sort of the early diagnosis, really right diagnosis to be able to start the right treatment and complete the right treatment in a timely manner is becoming even more crucial. And the idea was with the end TB strategy, which I think is still to 2025, which I think they're moving the goalpost a little bit now to be realistic, but still it is about getting universal susceptibility or resistance testing, and that's not achieved today. Less than 50% of these patients are getting diagnosed, and only 2 in 5 are accessing treatment, the right treatment. So I think there's a lot to be said for why more is needed for TB. There is a lot more to be done because there's a long way to go before we reach that goal and target here. And the other part, of course, from the clinicians in the room, and this is more of a Tim's slide, very much on just the treatment regimens are complex for TB. I think looking at it's great that we have all these new drugs after about 40, 50 years. But this also means these are new drugs that we hope can be sustainable for a while in the community. We don't want to lose the efficacy of these drugs too soon. We don't want to sort of create and be in a way promoting resistance too soon, which we know will happen over time as you deploy treatment. So I think the updated regimens are a big part, where there's shorter treatment regimens, great, but that also means that your diagnosis cannot take a month or two. That's eating into half your treatment time. So you really want to be able to get the right diagnosis, to know what the patients can be treated with or not treated with right at the start. And so this really calls for something that can give you the answers, a comprehensive answer when you're doing the testing. So that's why the case really for sequencing, and in our case, very much on targeted sequencing. Because again, the standard of care currently is with phenotypic drug susceptibility testing. Even with liquid culture, you're still talking about the 4 to 6 weeks plus a couple of weeks usually. So this is more the average we see in countries itself, 6 to 9 weeks to get a result. Meanwhile, patients are somewhat usually even started on therapy, and not everyone is even getting this DST because it's going to take this long. Sometimes clinicians have to make a decision based on, let's start here. If it fails, let's go back, which is really not where you want to be if you're really looking to end this disease. So whole genome sequencing, obviously in a lot of countries, New York State and the UK, Netherlands, Australia, many of them are using whole genome sequencing for every TB positive patient, but this still requires culture. Which is feasible again in certain settings where the culture is being routinely done, but it's still going to add time to this 2 or 3 weeks. But so that's why targeted sequencing is something we saw feasibly from a technical perspective and from an operational perspective can be done directly from sputum. So we really want to be able to see how do we make this into generate evidence to say this can actually work. This performs, this works, and can be done. Again, no need, as I already said, the big part in TB, why this makes sense more than any other pathogen one, you just see what we're working with, the standard of care. So it's such a slow grower that you want to be able to do anything to avoid or eliminate or reduce the growth time, the culture time itself. So this is one of those, this actually takes advantage of that. And overall for sequencing, just the fact that it is scalable, it is high throughput and so on, and just biosafety requirements lower because you're not growing up the bug. You in fact have it by then it is treated and inactivated to be able to do all of these processing. And essentially with sequencing, you're talking about something that's adaptable to new genes, new mutations, new targets very quickly. I don't have to go back to the drawing board to create a brand new cartridge or product. And overall, I think the whole aspect of you don't want also to be telling countries that already have limited health resources to be buying multiple platforms for different diseases, different health programs. This is one of those that is truly multi-pathogen, multi-disease, even not just pathogens. So it really has the potential to be that game changer for DRTB diagnosis. So the Seq&Treat work that we initially mentioned was very much on designed to generate the evidence and catalyze in-country capacity to be able to support this uptake and adoption of end-to-end solutions for targeted sequencing for drug-resistant TB detection. And the areas we worked on that I'll elaborate a little bit more as we go on would be the first one being, of course, the evaluation, really the basis on which for the entire project is analytical and then lab clinical validation for these different solutions that were on the market at the time. And in the same time, in parallel, building up that knowledge base. So having a catalog, having a list of truth on what each mutation means, what resistance is encoded by what mutation, and hence to be able to interpret the calls that you're getting from these solutions. Third aspect being very much on the implementation. How do we implement this now that we have, okay, performance is there, but how do we help countries and already start even before as the clinical trial goes on, help countries start thinking about planning for bringing in sequencing or expanding the utility of sequencing from their respiratory and COVID sectors into TB. And the fourth really being a lot of this on global procurement, ensuring these products are actually listed in global fund and other things, because a lot of these countries are reliant on global fund and so other procurers to be able to, other such global procurement lists to be able to get access to these products, any diagnostic products for TB and HIV for that matter. So going on to the analytical and clinical evaluation itself, I keep talking about end-to-end solutions. So really, because sequencing is still a workflow today and not a single box, fortunately, it is still a setting up this lab workflow. So our idea was to actually tell manufacturers, hey, we agree that yours is super flexible and you can work with any extraction system, any library prep, any sort of all sorts of combination. But for this purpose of this study, please pick one that maybe you have the most data on, most validated, pick one and keep that as a locked workflow that we can then evaluate independently of you guys. So that was very much right from the extraction, the library prep, the actual targeted sequencing itself, the data analysis, all the way to generating a report. So really making sure right from sample to result, the manufacturer in a way is responsible for that entire workflow. So the first part was essentially the analytical validation in the lab, where we sent a set of pre-arranged samples. These were sort of blinded samples sent to these panels, sent to the manufacturers to evaluate, just to see, ensure that these tests can essentially call what they claim they can call for. So this way we could build a panel with all the possible mutations ever within them, because we know that when we go to a clinical setting, we're likely not going to encounter all of these, and we won't really be able to test the extent and expanse of the test itself. So this was good because I think the phase one was a good way to actually say, okay, among these, do they all at least meet this minimal criteria? Analytically, do they perform? So it was clear that yes, all the products we evaluated in this case, there were two that fully made it now that we have the full data for that was submitted to WHO. So that's one is the GenoScreen combination with an Illumina. The other was a full solution from the Oxford Nanopore Technologies group. And so the initial phase one definitely showed that when a SNP is present, when there's a mutation present, it is called accurately mutation-associated resistance. So the next phase was to see, okay, that's great. It works analytically in a lab. Let's take it out to the clinic itself. Again, a trial, a multi-center cross-sectional trial, a diagnostic accuracy study across 3 countries, Georgia, India, and South Africa, really to get that coverage in terms of and the diversity in terms of the drug resistance populations, in terms of the burden of disease and so on. So, and also very, very different health systems. So this was over 750 patients, really looking at TB, confirmed TB patients, pulmonary TB patients at risk for drug-resistant TB, looking at the reference of a whole genome sequencing and phenotypic TST. And the idea was to really look at accuracy across a range of drugs, including the standard first line, second line, as they were called, but also for the bedaquiline and clofazimine, as much as we could, depending on how much resistance we see in the field, but to make sure, because these products did have coverage for these drugs. The composite reference that was used, as we said, was very much based on the catalog. So I'll come to the catalog. I'm sort of saying this before we talk about the catalog, but essentially, this is more to see what are the different products we used, where we had data from both phenotypic as well as WGS. Because the whole genome sequencing data was based on the catalog of mutations from 2021. Overall, in terms of success, I'm quickly getting into the results. We really saw a very high percentage of sequencing success across both these products, GenoString and ONT, which I'm indicating here. And the second graph below is very much on then sort of saying it if we actually disaggregated by the CT score. So CT values are the scores in terms of that GeneXpert gives, because GeneXpert was really the way into the trial. That was sort of part of the inclusion criteria, get positive on GeneXpert. We do know there's a correlation in terms of bacterial load for sequencing. In fact, for any molecular test, of course, then the idea was to see, is this, instead of just making it about smear positive, smear negative, can we do something a little more granular that actually says, okay, where do we see this accuracy? Where do we know for sure we will see a drop off? So it's clear that when you get to what is known as a CT low or CT very low values within GeneXpert calls, that's where you're starting to see drop off. Where it's really, the drop off is basically you're not getting any result. It's not a wrong result, but really you're not getting results for some or all targets. But overall, in the high score, medium score, and so on, you're still seeing very, very high, more than 80, 90% in terms of, and of course, very, very high in the high bacterial load. So I think this is more to say there is a correlation with bacterial loads, but very much cannot be just decided based on smear calls, because that's not, you're going to end up missing a lot of strains, a lot of results based if you just kind of disaggregate based on smear results. So based on the results itself, so this is more tables. We can go through it if there's specific questions. I think overall to say where the sensitivity was very high across the drugs, where you're seeing a low one on linezolid. There were specific cases that I'll come to specific situations. But overall, since this is based on the data, the known knowledge of mutations associated with resistance, you can very much see the sensitivity of very high sensitivity meeting the required sort of cutoffs, target product profile criteria for these drugs. Everything well above 98% in most cases, except for these couple of drugs. And for bedaquiline and clofazimine, this is in a way as good as it gets based on what is known in the field today of resistance-associated mutations. For nanopore, you see a similar one. Here, you do see much lower for clofazimine and bedaquiline, fortunately, but I'll come to why this was the case very quickly here. The overall, both solutions did provide essentially accurate, reproducible results. And as I said, more than 95% of the samples produced TB sequence data, just based on, again, bacillary load, where you saw the failures were mainly in those very low bacillary load samples. And then the high accuracy, the mutation list updating. So I think when it comes to sort of the linezolid and also the bedaquiline, clofazimine for ONT, a big part of it was essentially those targets, those mutations are not called by the manufacturers, in a way, software, the bioinformatics and reporting. So it is covered by the PCR, by the targeted PCR step. So essentially all this means is updating their lookup table and updating their bioinformatics should allow you to actually release these calls outside. So I think that was the most important and heartening to know, because that means very little change that I need to do literally in the bioinformatics to be able to increase sensitivity for these drugs. So as we said, I think looking really at the new drugs itself, for Biracoin and Clofazimine, so knowledge of mutations, one, updating it with the next version of the catalog, but over time, really making sure as knowledge of mutations grows, we are linking this up so that their software and hence their lookup tables and so on keep getting updated as knowledge improves on the association of resistance. I think similarly for ONT, the expanded mutation list is going to be key. And overall, you can see this is on the side that as long as we know there's a mutation and it's known to be associated with resistance, these products and these solutions are able to call them, which I think is key because now we know that the only change we need to make is very minimal to be able to keep updating them. And I think that's the whole idea of these being, and they can evolve along with as knowledge of the resistance mutations grows and very quickly be able to be updated. So the good thing was normally like it's a couple of months now, but for once we're still in the lifetime of the grant where we actually saw the results, the evidence, the clinical trial finishing, getting the results and being able to submit it to WHO and actually get the policy called out, at least a rapid communication on the policy. So it's very much I'm literally quoting from theirs to make sure, since it is WHO language, the available evidence supports the use of targeted sequencing to detect drug resistance after TB diagnosis to be able to guide clinical decision making. It's not a replacement, obviously, of the WHO rapid diagnostic test. So this would be your GeneXpert or your Roche or the PD Max, because those are giving you at least the initial TB positive and then potentially a RIF and or INH calls. But this is really beyond that for the comprehensive DST when required. And in many cases, you do require it, especially if you're looking at the new drug regimens. And overall, targeted sequencing is found to be accurate, still cost effective, depends on context, and overall implementable under routine conditions, although the reviewers did note it is inherently complex. And we did put it in very complex settings in India, Georgia, and South Africa, the top labs, but still they were not only dealing with the pandemic, but they also have routine basically diagnostics going on. So it was pretty amazing to see it in these real life settings, because these are the settings where these are going to be placed or will have the most impact, not necessarily in just a sort of a lab that's just doing research. So I think this was great to see in this context. There's obviously more implementation work to be done, but I think this was great just from a performance study to see everything else that we could gather in terms of what can we do better or what should we be considering when we deploy these solutions more widely. So this was the policy of rapid communication actually calls out to 2 different products for this different resistance. So it's really a evaluation based on per drug. So you can imagine the idea is this can be then updated quickly. The idea is over in the next year as more data is generated, say for some of the other drugs, for either that's Oxford Nanopore or for the GenoStrain. But pretty much GenoStrain Dplex Illumina combination met the criteria for all the drugs evaluated. Still, just keep me, I can't see if there's any hands, and I also don't know if there's any, the time-wise, just let me know if I'm.
Oh, you're fine time-wise. Just keep going. Yeah, we have plenty. We still have a half an hour, so you have lots of time.
All right. So I think I spoke about this catalog of mutations earlier, which is essentially to say, again, what is this list of the confident list of mutations that one can utilize to predict resistance from mutations. And so this was a catalog, this was many years in the making. I think this was something manufacturers had asked for, scientists had asked for, researchers had asked for, the TB community, clinicians had really asked for, saying everyone knows their list, or I can do a systematic review and find a whole bunch of mutations, but that's not really something that's in a way sustainable or also standardized or systematic, right? How do we make this sometimes actually make this a global good so that everyone actually starts with that same catalog? What they choose to do with that, if they choose to go beyond that, that's great based on their commercial or their requirements, their needs. But at the minimum for companies and manufacturers and researchers to be able to incorporate at least this set of mutations. Happy to say just a couple of weeks ago, version 2, a second edition of this was released. So we now have about 52 32,000 plus strains data in this that were evaluated and assessed for this catalog. It also has increased coverage. Now it does cover geographically in many more regions, but also coverage for the pedacul and delaminate. And of course, it already had mutations for clopasmin, linezolid, and so on. So essentially, the idea was this catalog really serves as this blueprint that companies, but also in a way that the community can utilize as a basis for molecular tests itself. Sequencing tests, of course, but if there are interests to build rapid molecular tests based on certain targets, this gives you sort of that, essentially that list that we need to be following to ensure your product has those targets. Now, in addition, WHO is also soon going to be launching this knowledge base. So obviously the catalog is one aspect of it, but all the data that fed into the catalog and to be able to understand some of the resistance patterns across the world, especially across different drugs. There's always been these reports that have generated, sort of reports in aggregate that one could go through as files or as, in paper form, which really wasn't ideal. So I think the idea was let's build an interface so that users, not just WHO, but really users and countries, most importantly, can actually access this and utilize this and see, look at dashboards to see what this means, the differences, what they should be keeping track of, or what they should keep an eye out for. So this is something, again, that was a long time in the making. It's just something utilizing this grant, we were able to build it for WHO. Now it's definitely of high interest for the AMR teams and others to say, can we have something similar for the other pathogens? That's going to be a lot more work because there does not exist such catalogs that we are aware of. And also to get those data sets, there's a ton of public databases for the different pathogens, but there's a lot of commercial databases as well. So I think TB is the one area where there were a few of them, but really we could bring together 2 or 3 of these existing ones like Cryptic, the Reseq TB, and a lot of other country surveillance data into this. We've got this really sort of the quorum of data that we can bring together. And we'll continue to populate it with the regular surveillance programs. But these aren't routinely done yet for other AMR pathogens. So I think that would be something that you would imagine would be a valuable exercise to start, which I think the AMR program has already started with some countries to be able to get the routine drug resistance surveillance going so that there is actual sort of data generated on a routine regular basis across countries to populate such a database, to even start to say, can we actually build a catalog of mutations based on all these integrated data sets? So the third aspect, as I said, again, with sequencing, I can't just stop there with the results and performance and data. Really need to think about implementation at scale. So a big part of this has been helping countries assess their readiness, and part of this is the implementation guidance. So I'll just come to that. This was also a tool that WHO just released in the last week. So this was, again, something where really the focus was on surveillance initially. It was 4 years ago when we started. There wasn't even a guide for doing surveillance with sequencing. So this was something countries have started doing already. But this was a way to actually take the learnings into one place and give checklists and tools and so on that countries can utilize to be able to start and set up sequencing in the right manner to be able to then initially use it for surveillance and then scale for patient care eventually when they are ready, when it makes sense for their program. Another thing I would highlight here was this whole diagnostic network optimization. Some of you may be familiar with it. But this is very much this was something we borrowed, I should say our field borrowed from the FMCG industry, from your Pepsi and Coca-Cola, because they use this all the time to say, how do you get a bottle of soda in the most remote setting? And they can, and you can go to any village and get a bottle of soda. Why can't we make diagnostics available that way? I think very much to say, using that same model, how do we map out how many sequencers maybe do we need, or how many diagnostic sort of rapid tests do we need, and the locations we need it, which makes the most sense and still cost-effective manner. So do we need additional sites, or do we need one big site and the cost of actually getting the samples there is actually balances out? So I think that's a big aspect that you can imagine for something like sequencing is critical, because I'm not trying to say a country needs 100 sequencers. They could do with 1, they could do with 5, but how do we set them up optimally so that the samples actually come to them and we are maximizing the health system's existing resources, not trying to add on more costs, which is not going to happen at the time. And then the third one I'll highlight here, and I'll go more detail, would be a costing tool. So this was something, again, that's been asked for. Again, we know genomics is not cheap, but to be able to say how for countries to plan this, but also programmatically for funders to also see what it will cost over time, knowing this is a volume of samples I'll get, and knowing this is over time, these are the number of types of samples or types of patients I would refer to for something for comprehensive TST. So the implementation manual, very quickly, it was very much designed for the PBE lab strengthening program support. So you can imagine the NTPs, the implementers, and so on, really looking at this. It looks across a number of different areas, starting all the way from country planning, where countries are thinking of, okay, how do we establish a national body to be able to make these decisions so that there's an actual committee to decide from a technology feasibility point of view, but also cost and implementation aspects. And then really gets into the details of right from the equipment, supplies, what are the products needed, regulatory-wise, the registration, customs, all those considerations that a country needs to have. Then the training itself, how do you build that capacity training across wet lab and bioinformatics. The SOPs required across, as you can imagine, there's quite a bit of this because there's many modules within a sequencing workflow. And then, of course, the data recording being a key piece. Right now, the great thing about this is it is digital data in a way you're getting from sequencing, but how do we make sure that's actually incorporated into the public health sort of system, the LIS and so on, not just something that's standalone and separate from everything else. And overall, the QA, QC, and evaluating how this is running over time, how do we make improvements and so on. So very much it is more almost a toolbox that countries can use, partners can use with different checklists and different assessments that they can utilize at different stages of implementation. And we have a nice example from South Africa in their case study, because South Africa has already been incorporating or implementing sequencing for surveillance for a while now. The costing tool, this is something we're very proud of. This has been more started for COVID. It was for SARS-CoV-2 at the time, but that was a good basis in which to build this out, because that's the first time companies actually build a specific kit for a pathogen. We've been asking them for years for TB, never once. And then for SARS-CoV-2, overnight, both Illumina and Nanopore was other companies, but they all built a SARS-CoV-2 specific sequencing kit that had all the components you need. All you needed was a sequencer and potentially the extraction system, but you could pretty much run it with that kit. That's not the case today for any other products, but it's just starting to happen. You're starting to see that for TB. You're starting to see that for some of the other pathogens. So I think this is going to be key to make this something that can be programmatically utilized. You don't want countries and groups or labs to be making decisions based on 10 different or 20 different SKUs from 10 different manufacturers. So this is key in being able to consolidate, but also to be able to routinely place these orders, procurement, supply chain, and so on. So this tool is something we built together with the WHO, the WHO Euro region, the APHL from the US, the UK HSA, and the Global Fund. So all the groups that, we all get requests for this from countries, from our partners. So this was, we knew we had all had various iterations and versions of the tool. So when there was an opportunity to actually combine forces, we're like, yes, let's just bring all this together. We don't need to be building our own tools separately and for our little constituency. So this has been a really nice example of working together with these groups and really cross-country to build and then pilot these across countries. Again, each of these partners has a different set of countries or an overlapping set of countries they work with. So that gave us an immediate test bed to be able to go and validate these tools, improve it or rapidly, make those updates, and actually then run it by, again, these countries and more countries. And so you can imagine now it should be, the idea is to then expand this for other pathogens, for TB being the next big one that countries have already been asking for. They're like, COVID is great. We've done that. We really need this for TB because that's where we're doing the planning now. Just coming, this last section is more a little bit on some of the technology updates. So this is sort of we just got an extension for our grant, which we're very grateful for. So this one very much focuses on both from the country side uptake, how do countries want to implement it and uptake, as I said. So that's one aspect, and I can speak more to that if that's of interest. But the other aspect is also knowing the landscape is changing, is shifting, is growing very rapidly. Again, 5 years ago, Tim and I we spent, I don't know, countless hours trying to convince companies to even invest in TB. And any of y'all that work in TB know this is a losing case. Like I can't possibly make you a huge business case with TB other than volumes. But it is such an important area that if companies aren't convinced, or this is not compared to everything else they do, we're not really going to get them to the table. And it's not on sort of NGOs and researchers to start just build the products. We really need commercial entities behind this who can actually bring this scalably and sustainably to the market. So very much our focus was that. But now I think companies, the large sequencing companies, actually have a huge install base now from COVID. So they have this, what used to be their upside is now their market. They have sequencers sitting in all over the world. They have sequencers sitting all the way from Papua New Guinea, in Botswana, in Eswatini, and so on, areas where they weren't really thinking of going there. They're like, if they buy it, awesome, but that's not really where we're building this for. And now that it's there, their whole business model is about making sure it is run. And what are they going to run after COVID? TB is the next big thing that countries have asked for. They're seeing the value there. Companies are suddenly looking up, okay, that's an opportunity. So I think we needed to wait for this from a shift change from the market, not just us making that sort of demand from sort of a TB community side, but really for companies all to see this as a business opportunity, because then the innovation is going to come, the products are going to come, the actual supply chains are going to be set up. So that's where we are, where there is that sheer interest from companies and engagement from companies to be here. But that means this is where we can talk about things like improving workflows. Again, the simple end-to-end workflow that I've shown before was all well and good, but really each of these steps has a few things to do at each of these stages. It's still quite complex for labs to run. Countries are running it. I mean, programs are running it. That's not once they get trained, once they're able to run this, that's not a problem. But why can't we make this simpler? Because they have made this simpler for other applications. So I think there's a lot of advances. Again, there might be a lot of more tech-heavy folks in the room, so I don't need to, they'll know way more about this. But I think overall what we are trying to do is at least do a landscape of what are those sort of improvements coming way, in a way to build that map of, okay, there's improvements in the workflow itself, in automating these. Automation obviously comes with costs, but there's also the benefits of less hands-on time, less human error, and so on. So there's interest in automation across these different steps. There's also interest in integrating some of this. So you can imagine the extraction and the library prep potentially, or the library prep having less hands-on time, less about 20, 25 PCRs, but sort of a single step that can actually help enrich for your target areas of interest. There's also, of course, from the data analysis perspective, there's a lot of interest. What used to be quite, people were wary of some years ago has now become routine. People are used to, in a way, uploading data, sharing data on the cloud, and being able to get analysis on the cloud, even if it's within something servers that are based within their countries or regions. So I think that has been an important advancement that we're seeing, and a change in the mindset itself. And that's important because, again, we don't want, everyone cannot and should not be trying to handle terabytes of data in their own systems, in their own sort of health facilities. I think that's been a big one. And of course, from the data analysis, we were saying from the mutations catalog, a lot of it is still based on people, experts reviewing the data, but there's a lot of programming, coding going in. We are trying to see how best we can also automate this and get in some machine learning tools to be able to make this more, utilize the predictive and analytical aspect of this, so that we're not, again, this is something we needed to be sustainable over the next several years. It's not something we can keep bringing together, getting a grant, bringing together a group of people to evaluate this. It should be something as automated as possible, that then you have experts just to do the last, in a way, the validation to make sure, okay, these make sense, and these are the new additions or the changes we'll do to a catalog. Bringing this specifically to the TNGS workflow for TB, we said the automation is a big one. DNA extraction, of course. Right now, what we did was from sediment, of sputum sediments, because we obviously had to split it across. We're seeing a lot of labs would be interested in using sediment as well as a starting material, because again, they're still want to keep some phenotypic, still want to be able to do other molecular tests as necessary. But this could change over time. They may be doing a rapid test and may want to use the remnant of that sample to be able to send to sequencing, depending on whether it's positive or not, or there's a risk of drug resistance, or they see a need for comprehensive DST. So how do we make sure that extraction, what are the different types that we can actually validate to say this can work on multiple settings, not just what we did in our clinical trial. The library prep steps, as I already mentioned, the data analysis, so really making sure now these are updated with the second edition of the mutations catalog. A lot of this is going to be primarily, as I said, bioinformatics changes. In some cases, it could be actual changes, addition of new targets, new regions itself, which means the wet lab changes as well. This is not something immediately, but you can imagine companies and would want to do this because there's newer targets, or as we targets for newer drugs like predominant and merge. This is going to be key because these are not necessarily gene targets that are also covered by other drugs resistance today. These would be some of the areas that we're seeing where there's improvements, or there's something we'll be tracking over the next couple of years to ensure that at least there's this list, and hopefully make a case for why there should be investment in bringing some of these, advancing and accelerating some of these and bringing them to implementation. And of course, the whole genome sequencing, I started off saying why we're not doing whole genome sequencing, but that still comes up every time from countries, from everyone, that this is something I know in countries like the US and UK can do this today, even if it's from early midget cultures. But there is some interest, and there's some research at least on the way on being able to do this directly from sputum. There's different ways. Obviously, you want to enrich for the bug, you want to enrich for the bacteria itself. At what stage do you do that? Rather than doing a targeted PCR, can you actually do that from starting in the before cell? Can you do some baiting? Can you do some enrichment within the DNA itself for the bacterial DNA, for TB DNA, for that matter? So I think those are different areas where we're seeing this work going on. Again, this is something to track because countries and programs are interested in. Hey, it's great, we'll start with targeted, but we will be doing whole genome sequencing from cultures for surveillance. Eventually, it would be great if we could, it's that potentially something we could use for patient care so that we're getting all of the information, not just these targets. So that's something we'll be tracking, and I'm sure the TB community will be tracking over the next few years itself. Now, really bringing this to the close here, I was saying there's a lot of this COVID-19 investments and capacity that was built that we really should be leveraging for TB and really deep beyond TB. So we saw about a 40% increase in capacity in sequencing across the world. So this is really when WHO maps it across countries, we're seeing that increase in just the 2-year period, which is pretty fantastic given, these are all areas where in the past it was really thought, okay, these countries can never do sequencing, let them send the samples elsewhere. So no, these countries have built that capacity. They have the ability to do the sequence in-house and actually utilize that data as well, not just generating it for someone else to analyze and research. So that's something as fine we continue to do, mapping not just the capacity of sequencing across the world, but also the investments. So there's an activity we're doing with Wellcome Trust to see what are the different investments in pathogen genomics by the different donors and investors, and where do we see this going? The idea is to really see across donors that there is actually momentum in investing in genomics, and so how do we make sure it's actually equitably distributed? So it's not the same few countries or the same few topics getting all the attention and the money, but it actually there's coverage for all the priorities that are needed in the world of global health. Capacity building is something FIND did quite a bit during COVID. This continues to be a need, big demand from countries. So we of course partner with groups like APHL and CDC and so on, where the idea is even if we don't go out there and do it hands-on on the ground, we can build the tools and different guidance tools that countries and partners, implementers can utilize. So this is along that realm of global guidance. These are all things that we worked on with WHO and other partners. industry engagement I already emphasized quite a bit, is a lot of work we're doing in terms of the market shaping, ensuring there's access pricing for these products, but also from the supply chain side. I think other than the basic products that we didn't have access to as consumers, obviously you can imagine something like sequencing was definitely affected by shortages of, say, one product. That means you can't sequence a genome because one little kit of sample prep or one little kit for library index test is missing. So I think that's the idea, that we want to make sure supply chain is in place, and companies are thinking of this for regions that they in the past didn't really serve in a large basis. And as I mentioned, global fund, but this is more to say that outside of being able to build capacity, how do we help countries actually access some of these grants? The great thing we've seen is a lot of the funding is going to countries directly now through the World Bank, Pandemic Fund, the Global Fund, and so on. So a role for us and for implementers, those looking to, in a way, help build capacity in countries, to say, how do we help strengthen the applications of these countries so that there is a clear programmatic utility and sort of a clear strategy in terms of how they'll scale this over time, how they'll implement it sustainably and scale it over time. And that's a big role, I think, we see for the TB community, for sort of partners that have been engaged in implementation and in the technology aspect, saying we should still help countries, even if we are not out there doing the work on the ground. How do we help make sure their applications are strengthened so they are able to get access to these products and be able to use them in a meaningful manner right from the start? So it's sort of making the most of what they're getting access to with all these funding programs that are in place, hopefully to make a case for the countries themselves, for the ministry's domestic funding to kick in when they do, to continue the coverage for these, for genomics, for TB and other diseases. I think that's all I have. So it's all of these donors, Unitate being the big one for us for our TB work, but also many of the other donors that have also supported during COVID, a lot of the country partners, and of course the team. We recognize it was Tim there, Becky Coleman as well, who's sort of led the charge on all of the sequencing, the TNGS work, Marva Seifert, who also led the work on a lot of the analysis, the data, the statistics work. And yeah, that's, thank you. We have you for any questions or.
Wow, that's great. Thank you so much, Anita. That's just amazing work and very, very impactful. So we really do appreciate you speaking today. If anyone has any questions, please feel free to speak up. We're pretty informal here, so just fire away. Or if not, I could ask. Oh, go ahead. Yeah.
I have a question. I was wondering for the linezolid and the bedaquiline and clofazimine, and maybe you said this and I just missed it, but what do you think is causing the less ability to achieve, predictive value from the sequencing?
I'll let Tim answer to the linezolid bit a little bit because there is some complexity there. But I think for the other two drugs, it was clearly a matter of these calls weren't even being made by both these products, right? So they actually had the coverage for those drug targets. So we know the ones they should be calling, if they had called them, essentially, if the software had called them out, they would have achieved a much higher percentage of sensitivity, as much as can be achieved today, knowing what's known. So over 80%. Just that they did not have these mutations called out, so they were never flagged in the final report as associated resistance. So that was a big reason for most of the drugs. Linezolid was part of it, was that reason, but linezolid also had issues because the phenotypic DST is also flawed in some of these cases. So that made it also an issue where, like, is it the phenotypic that's giving that is the error, or sort of is it WGS? Is it us not having the right targets or the correct enough targets in there? Tim, would you add something there?
Yeah, I think it's exactly what you say, Anita. Anika, it's a complex issue of genotype and phenotype. We don't have a lot of targets for linezolid. The ones that we do have are excellent, but in the entire mutation catalog, not just in the trial. In the trial, there's hardly any phenotypic linezolid resistance detected, so the confidence intervals are huge around our estimates of performance. But more importantly, in the mutation catalog, where we've got a lot more bugs, a lot more phenotypes, a lot more genotypes, it just doesn't turn out that those mutations have a lot of sensitivity for prediction. And I honestly don't think it has anything to do with mutations. I think it actually has to do with the fact that the phenotyping for linezolid is terrible. So, excuse me, for example, if we threw out one of the countries for the trial and just focused on India and South Africa, the sensitivity would have been closer to 80 or 90%. So in one of the countries, sorry, excuse me. Sorry, Anita and I are suffering the same thing. We both got COVID from the meeting we were just at. So in the trial, one of the countries, their phenotyping just wasn't very good, and so it brought the sensitivity down for the whole thing. So I think this is it's just a combination of very low prevalence of real linazolid resistance out in the clinical world, so 1 or 2% prevalence in the whole world for linazolid, and problems with phenotyping, so that when we do these large genotyping-phenotyping associations, we don't get the best data because the phenotyping itself is not great. So all things we can improve.
Great. Any other questions, anyone? All right, and just give me a moment. I'm going to introduce our speaker for next month, and then we'll wrap up. And again, Anita, thank you so much for your time today. It's just been a pleasure. Really appreciate that. All right, one second. All right, so our next seminar is coming up fairly shortly on December 11th. We'll have Dr. Aaron Carlin, who is one of our developmental grant recipients. He'll be speaking on his work at that time. So please do attend that if you can. I believe the invites have already gone out, but we'd be happy to see any of you here. And we are looking at speakers for next year. So if anyone has any recommendations as to, Tim, thank you so much for this as well. But if you have any recommendations, further ones for anyone who could speak next year, please let me know. I'm very grateful for any suggestions. And with that, I'm just going to thank everyone for their attendance, their time, their interest, and this will be posted up on our YouTube channel within the next week or so. So thank you all for your time. Anita, thank you. And I hope everyone has a very pleasant evening and a very good day. Take care, everyone. Bye-bye.
Thanks, everyone. Bye.